Hi, welcome back. Today we're going to find the specific terms in the product of binomials. Again, we're going to do so using the general term. Now, I'm going to assume you have watched my previous lesson, so I'm not going to talk too much about the general term, but here's a recap of the formula. So let's try example 1. Find the coefficient of x to the power 12 in the expansion of bracket x squared plus 3 over x to the power 6, bracket 1 minus 3x cubed. Now, if you look at this expression, the first one is a binomial with power 6. The second one is just an expression without a power here, so just power 1, right? So we probably don't have to expand anything for this. Okay, so x to the power 12. Never mind, let's do our general term first. TR plus 1 equals to 6 choose R, first term, second term. R comes up to the power of the second term, and this is 6 minus R. Okay, so I'm going to, I need the power of x. All right, but right now there's an x in the first term and x in the second term. So I need to separate the second term out and then join the x together. So 6 choose R. Let's simplify this. 12 minus 2R. And then this is actually 3 to the power R and x to the power negative R because the x is in the denominator, right? So now that I've separated the second term out, I can join these two x together. So 6 choose R, x, 12 minus 2R plus negative R is 12 minus 3R and 3 to the power R. Okay, now I have a 1 minus 3x cubed here. If I want an x to the power 12, a constant 1, meaning x to the power 0, what must I times to get an x to the power 12 term? Now, if you know your indices well, you should know you need an x to the power 12. Okay, because 0 plus 12 equals to 12 by laws of indices. Okay, also, if I have a 3x cubed here, so if I have an x cubed, what x term do I need to get x to the power 12? I need x to the power 9 because by laws of indices, you get 12 here. Okay, so I need an x to the power 12 term and I need an x to the power 9 term. So let's try to get our x to the power 12 term. So I want my x to be power 12 and therefore my 12 minus 3r will be equals to 12. 3r equals to 12 minus 12 equals to 0. So r equals to 0. Nothing strange, okay? So now, if I use r equals to 0, 0 plus 1, I'm finding my term 1. 6 choose 0. X, 12 minus 0 is 12, which is what I want, right? Over here, x to the power 12. And 3 to the power 0. So in fact, 6 choose 0 is 1. 3 to the power 0 is 1. So it's just x to the power 12. Okay? Next, I also want x to the power 9 term, right? So 12 minus 3r equals to 9. 3r equals to 12 minus 9 equals to 3. And r equals to 1. So my r equals to 1. Therefore, in my general term here, I'm finding actually 1 plus 1. I'm finding my second term. 6 choose 1. X 12 minus 3r, which is 9, which is correct. That's what I'm trying to find. And 3 to the power 1. So 6 choose 1 is 6 times 3 is 18. 18x to the power 9. So now I have these two terms. I can do my expansion to find the x to the power 12 term. So I can simply write x squared plus 3 over x to the power 6 times 1 minus 3x cubed equals to, these two terms are part of the expansion, right? X to the power 12 plus 18x9, and I don't have to care about the rest of the terms. So I just put plus dot 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 times the second expression, 1 minus 3x cubed. So now, let's use a red pen. To get the x to the power 12 term, this x to the power 12 must multiply to this 1, and this 18x to the power 9 must multiply to this negative 3x cubed. Okay, so what's x to the power 12 times 1? Isn't it x to the power 12? And then what's 18 times negative 3? Is minus 54x to the power 12. And therefore, I get minus 53x to the power 12. So they want the coefficient, right? Therefore, coefficient of x to the power 12 equals to negative 53. Okay? So you have to be very good in your laws of indices and be clear what term do you need to times to this 1 to get x to the power 12, and what term, again, do you need to times to this negative 3x cubed. All right, which is what is over here. Okay, so let's move on to example 2. Find the coefficient of x to the power 6 in the expansion of bracket x squared plus 4 over x to the power 6 times 1 minus 2x cubed. Again, here there's a power. This binomial has a power here, power 6, and this has no power, which is just power 1. So I need an x to the power 6, right? So, okay, I'll talk about that later. Let's try to find our general term. TR plus 1 equals to 6, choose R, x squared, 4 over x to the power R, and this is 6 minus R. Again, there's x in the first and second term. I need to split the second term out to get the x out. 6, choose R. Let's simplify this. X, 12 minus 2R, 4 to the power R, x to the power minus R. Again, because x is in the denominator, so it becomes negative power. So now that I've separated this out, I can join the x up. 6, choose R, x, 12 minus 3R, 4 to the power R. Now, again, here comes the most important part. What powers of x do I need to times to 1 to get x to the power 6? So 1 is actually x to the power 0, right? Because it's independent of x. So what do I need to get x to the power 6? And then also x cubed minus 2x cubed, right? What x to the power do I need to get x to the power 6? So laws of indices, I need x to the power 6 because 0 plus 6 equals to 6. And I need another x cubed because 3 plus 3 equals to 6. So I need an x to the power 6 term and an x cubed term. So let's take our 12 minus 3R. Let's do the first one, equals to 6. 3R equals to 12 minus 6 equals to 6. R equals to 2. So let's find our R plus 1. So third term, 6, choose 2. X, 12 minus 6 is 6, which is correct. That's what we want to find. And 4 square. So let's use our calculator to evaluate this. 6, choose 2 times 16 is actually 240 x to the power 6. Okay, again, now let's find our second term. We need an x cubed term. So our 12 minus 3R has to be equals to 3. So 3R equals to 12 minus 3 is 9. R equals to 9 over 3 is 3. So now, right now, we're finding the R plus 1 is 3 plus 1, fourth term. 6, choose 3. X, 12 minus 3 times 9, so it's correct. X cubed. And this is 4 to the power 3. So 6, choose 3 times 4 to the power 3 is 1280 x cubed. Okay, so similar to the previous example, the presentation I want to write is x squared plus 4 over x to the power 6, 1 minus 2x cubed. So this is a question, right? So now, in the expansion of this, I only need these two terms. Okay, so 240x6 plus 1280x cubed plus, I don't need the rest of the term, so I'm just going to put plus dot dot dot. Okay, times 1 minus 2x cubed. So again, let's change to our red pen. To get an x to the power 6 term, I need to take this times this, and this times this. So what's 240x to the power 6 times 1? Isn't it just 240x to the power 6? And what's 1280 times negative 2? Make sure it's negative 2, don't just take 2. So 1280 times negative 2 is minus 2560x cubed. No, x to the power 6. Okay, which is, actually I still have to put my plus dot dot dot, equals to 240 minus 2560 is minus 2320. X to the power 6 plus dot dot dot. Okay, and therefore coefficient of x to the power 6 equals to negative 2320. All right, so we can move on. Key points to note: in the product of a binomial, usually one term will have power 1, so you do not require expansion. The other binomial will have a higher power, which requires your expansion. But we're not going to use expansion here. We're going to use the general term, right, to find specific terms. To find a specific term required, for example, x to the power 7 term, first, you need to get a general term, then think which terms must be multiplied to each other to get the x to the power 7 term. For example, if I have this, maybe 4, okay? And that's my binomial expansion here. I want an x to the power 7. Okay, I got my 1. What do I need to get x to the power 7? I got my x to the power 4 here, from here, right? What do I need here to get x to the power 7? By rules of or laws of indices, it's x to the power 0, right? So let's change this. This x to the power 0. I need an x to the power 7 because 0 plus 7 equals to 7. And for here, I need x to the power 3 because 4 plus 3 equals to 7. So be very sure of this. If you're not good in your indices, you're going to have problem with binomial theorem. Okay? So hope you learned something from this video. Please give my video a like if you have learned something and subscribe to my channel for future content. Thank you very much.